So for our warm-up, what I really want to quickly do is go through what we talked about in our previous lesson about a histogram, right? So it says, according to our histogram, how many 60 to 7-year-olds are there? So 60 to 7-year-olds is right here, right? This is our 60 to 7-year-old category. So we go all the way up and we say, well, what is my frequency? So that's pretty straightforward. Nothing too crazy there. So my frequency was, there we have 3 of them. But if it says what is the mode, right? What is the mode? A lot of people tend to say that the mode is 5 because we have 5 of those. Well, that's not true, right? The mode isn't 5, but that 5 helps us know which age occurred the most. So which age occurred the most? 50 to 60-year-olds. So our mode is actually our 50 to our 60-year-olds, right? That's what the actual mode is, but it was because that was our highest frequency, 5 of them. Then the next question says, well, how many people are over the age of 60? How many people are over the age of 60? Well, over the age of 60 is these guys and beyond. So if we look at that, that's these 3 people, then 1 person here, 1 person there. So that's a total of 5 people, right? We have a total of 5 people that were over the age of 60. And then last but not least, like we did in the last lesson, how many people were surveyed in all? Well, we know it's those 5 people plus 5 more, that's 10, plus 4, that's 18, plus 2, that's 20 people altogether. So a good little recap there of histograms. But what we're looking at today is would have been on Desmos, and it's about standard deviation. So standard deviation is a reminder, is just about how spread out your data is. So the first thing we're going to look at is how we can use histograms to compare spreading out your data. So we're going to have 2 histograms here, and it says that the mean for each is given, but we don't really care. That's that the mean is 1.93 and 2. But what we want to look at is which of these has a larger standard deviation than the other. Or if they have the same, you can say that they have the same. So it's key here to look at how spread out your data is from the mean. Remember that that's what standard deviation is, that how spread out the data is from the mean. So in this particular case, what I want you to look at is the fact that the second graph, your mean is going to fall right here. Your mean is 2, right? Your mean is 2. So you'll notice that most of our data is further away from that mean, right? Most of our data is further away. Our high frequencies, are over here, as much, much further away from the mean than, as you compare that to, our mean here is about 1.9. So you'll notice that most of our data is close to that mean. It's much, much closer to it. So if that's the case, this is going to have a low standard deviation, and this is going to have a high standard deviation. So the higher standard deviation is B. B definitely has a higher or a larger standard deviation than A, because of the fact that your frequencies are much higher further away from your mean. That's how we measure standard deviation. So let's try another. When we look at this one, again, our means here, we have them 5.3, 5.4. But again, we can start to just look at these shapes, and we can look at the fact that anytime we have this more of a mountain shape versus we have a bit of a mountain, then a spread here, we have a bit of a valley. So when you have valleys, valleys indicate, so valleys, right? Valleys indicate a larger standard deviation. Mountains, mountain shapes, right? A mountain shape indicates a small standard deviation. So mountains are small, but valleys indicate a large standard deviation. So in this case, graph A would definitely have the larger standard deviation, graph A. Next question is pretty cool, because if you look at those, what do you notice? What do you notice about graph A and graph B? If you notice, they're actually almost the exact same graph. They've been flipped, right? They've been flipped. So if that's the case, you can see that we have this here with a small valley, same small valley with a mountain there. But again, they're the exact same graph. They've just been flipped. So even though their means are different, they're the same distance from the mean because your data are spread out the same. Your data values are spread out the same. So they have the same standard deviation. All right. Just a couple more real quick. You try these on your own. Press pause on the video if you need to, and take a guess as to whether you think A or B has a larger standard deviation. So looking at these right here, our first one at graph A is very uniform. Our graph B is a bit more normal. So in this case, even though these have higher frequencies, wrong key there, even though these have higher frequencies, high frequencies don't mean high standard deviation. This is actually more spread out. This data value here is more spread out. So in this case, graph A is going to have the higher or the larger standard deviation. Wrong thing again. Graph A is going to have the larger standard deviation. So now that you've kind of got that sorted, you think graph A or graph B. So you're like, well, graph A was just the answer in the previous question. It hasn't changed. But it's less spread out because we have this valley shape here, right? We have this valley shape. So in this case, graph B is going to have the larger standard deviation in this example. So now we've kind of dived into these standard deviation histograms, and we look at how the standard deviation can be compared between two histograms. Very important stuff.